Welcome to episode 396 of AI Brief. I'm Amin.
And I'm Leah.
We are looking at a stack of stories today that it really suggests we're crossing a very specific, very important threshold in artificial intelligence.
It does.
It feels like we are finally moving from the era of, smart chatbots.
The ones that just sit there.
Exactly, just waiting for input, to the era of autonomous agents that actually go out and get things done.
And that distinction is everything. A bot that talks versus an agent that acts. That's really the thread that ties this whole deep dive together.
Right.
We aren't just looking at text generation anymore. We're talking about open source frameworks, moving intelligence off the cloud, Google DeepMind trying to solve, well, the physics of 4D space.
And robotic hands that literally detach and crawl away.
It sounds like pure science fiction, but the documentation is all here.
It is. We have a lot to get through, including a roundup of some pretty wild robotics news and a toolkit that I think is going to boost your productivity.
Yeah.
But we have to start with the headliner.
We do.
We are going deep on Clawdbot.
So this is an open source framework from Peter Steinberger, and the core promise here is it's aggressive. It's making the case for running autonomous AI agents locally.
Locally. On hardware, like a Mac Mini, the notes say.
Yeah.
And right away, that signals a shift. I mean, for the last 10 years, the whole narrative has been cloud is king. You want smarts. You call an API. You send your data off to a server farm somewhere. Clawdbot is basically saying, no, bring it home.
It's a total reversal of that trend. Now, it uses models like Anthropic's Claude, but the execution, the whole environment, is local. It runs on your metal.
But the tech architecture isn't even the most interesting part. It's the behavior.
It's the proactive element.
That's the part that really got my attention.
This the killer feature. I mean, think about every interaction you've ever had with ChatGPT or Gemini.
It's reactive.
It's completely reactive. It just sits there, blinking, waiting for you to type something. Clawdbot flips that polarity. It initiates contact.
Which just changes the relationship entirely. It goes from being a tool, like a calculator you pick up,
to being an employee who knocks on your office door.
That's the perfect analogy.
Right.
Imagine you're working and you just get a ping. It's not spam. It's your local agent saying, hey, I noticed this meeting request conflicts with your flight. Should I reschedule?
Or I've drafted a response to that email you've been putting off.
But for it to do that, it can't just be a text box. It needs access. The documentation says this thing hooks into local tools people actually use every day.
We're talking Gmail, iMessage, calendars, and it processes natural language through pretty much any messaging app, WhatsApp, Telegram, Discord, Slack, Signal.
That integration layer is crucial. If an AI is going to be proactive, it has to live where you live.
It can't be trapped in a browser tab.
And it goes deeper than just reading messages, right? Clawdbot has access to the file system.
The shell.
And browsers. It can actually execute tasks.
Giving an AI access to the shell, to your command line, that is a massive leap in capability. It means the agent can actually control the machine. It can run scripts, move files.
That sounds incredibly powerful, but also, a little serious, giving a piece of software that kind of autonomy, if it hallucinates, could it do real damage?
Well, the developers thought about this. The framework includes sandbox options, for safety when it's running scripts.
So you can wall it off.
You can wall it off so it can only play in a specific area. But the trade-off for taking on that risk is something they call persistent memory.
Okay, define that. Because memory in an LLM usually just means the chat history in your current window.
Exactly.
Yeah.
You close the tab, the brain resets. Clawdbot remembers things over time. It retains context, and it improves through skills and plugins. It's building a localized model of you.
So it remembers what I asked last week, how I like my files organized.
What projects you're focused on. And because it's local, this all ties into the privacy argument. You're not sending every single query and file to a third party.
That's the whole edge AI argument. Data ownership.
You own the compute, you own the context. But there's a business disruption angle here, too. Think about a company like Zapier.
Zapier is the glue of the internet right now. It connects App A to App B with APIs.
And you pay a subscription for that. Clawdbot offers custom local automation. So if you have an agent on your Mac Mini managing your sauce tools and creating content without a middleware fee...
That's a direct threat to that whole automation business model.
It is. It's moving from renting intelligence to owning it. The takeaway here is, well, it's pretty stark. If you aren't trying Clawdbot, you might be missing a fundamental shift in how automation works.
It's moving to the edge. And it's getting proactive.
Absolutely. It's a glimpse into a future where our devices aren't just terminals for the cloud, but the actual brains of the operation.
Speaking of brains, and perception. Let's pivot to the science portion of our deep dive. Google DeepMind has announced D4RT.
This is really fascinating stuff. D4RT stands for a unified AI model for 4D scene reconstruction and tracking.
Okay, 4D scene reconstruction. I think most people get 2D, that's a picture, 3D is a shape. But 4D, that sounds a little abstract.
The fourth dimension here is just time. So 4D is basically geometry plus motion.
Oh, okay.
Most computer vision models today look at a video and just see a series of flat pictures. They don't really get that the cup in frame 1 is the same object as the cup in frame 50.
So D4RT does, it's not just seeing pixels changing color, it understands an object is moving through space over time.
Exactly. It uses a unified encoder-decoder transformer architecture.
And transformer architecture, that's the same tech under the hood of things like ChatGPT, right?
It is. Transformers are great at paying attention to different parts of a sequence to understand context. We usually use them for words, but D4RT uses them for visual data.
So it's processing video to reconstruct the shape of the world and the motion.
Simultaneously. And in real time.
The real-time part is what jumped out at me. Usually doing this kind of volumetric reconstruction, building a 3D world from video, takes hours of rendering.
And that's where the innovation is. They use what they call a query-based approach. So instead of trying to calculate every single point in the universe, the model efficiently queries the data for specific points of interest.
So it's more like how a human sees. We don't analyze every photon. Our brain focuses on the ball being thrown at us.
That's a really good way to put it. And because it's so efficient, it outperforms previous methods across the board in these 4D reconstruction tasks.
So what's the application here? Why does this matter outside of a research lab?
Robotics is the big one. I mean, if a robot is navigating a warehouse, a static map is basically useless.
Because people and forklifts are always moving.
Right. To avoid a collision, the robot needs 4D perception. It has to know where things are going, not just where they are right now.
It's the difference between a robot that just stops because something's in the way
and a robot that smoothly sidesteps a person walking past. It's also huge for augmented reality and spatial computing. If you want digital objects to interact convincingly with your living room, the system needs to understand that room instantly.
And again, the source mentions potential for on-device deployment. So just like Clawdbot, the goal is to get this heavy lifting out of the server farms and onto the robot or the headset itself.
It all connects back to that theme of autonomy. The intelligence is moving closer to the action.
Okay, let's shift gears now. I want to slow things down just a little bit here because we have a roundup of stories that really show the sheer variety of what is happening in the field today. We have updates from biology-inspired robotics, the autonomous vehicle sector, and even oceanography.
Yeah.
Let's start with the Swiss engineers, because this one creates a very, very specific mental image.
It is visually striking. Swiss scientists have revealed a detachable robotic hand.
The description immediately makes you think of Thing from the Addams Family.
It's a very apt comparison. The mechanism allows the hand to actually detach from the main arm, and once it drops, it uses its own fingers as legs to crawl around.
And then it just comes back.
It crawls back and reattaches itself. And the crucial part is that it can do all of this while securely holding an object.
Besides being just a fascinating piece of engineering, what is the actual use case for a hand that can run away?
Well, it solves a major problem in industrial inspection and disaster response. Imagine a collapsed building or a complex network of pipes.
A rigid robotic arm can only reach so far.
Right. It can't get around a sharp 90-degree bend or squeeze through a really narrow gap.
So the arm gets you close, and the hand detaches to crawl into that tight space.
Precisely. It literally extends the reach of robotics by letting go. It can crawl into a tight spot, inspect something, and then return to the main unit. It's really about access.
From crawling hands to self-driving cars.
Yeah.
We have an update from Tesla, and this feels like a pretty significant milestone. They're operating down in Austin, Texas.
That's right. Tesla has officially begun running fully unsupervised robotaxis in Austin.
Unsupervised. That's the key word there.
It is the only word that matters. For years, even with full self-driving, there has always been a human safety monitor in the driver's seat. You know, hands hovering over the wheel, ready to jump in.
Tesla has now removed that safety net, at least for a handful of vehicles in the fleet.
And this was confirmed by their VP of AI, Ashok Swami. The market reacted instantly.
The stock surged 4%, but more than that, social media was just flooded with videos of Model Ys driving around Austin with nobody in the driver's seat.
It signals a level of confidence we really haven't seen before.
It shifts the conversation from testing a technology to demonstrating a product.
When you pull the human out, you change the liability, you change the operational model. It changes everything. And they plan to gradually increase that ratio, so this is just the beginning.
Let's move from the roads to the oceans. We have a story about a startup called Ocean and their micro-robots. These little guys just survived a Category 5 hurricane.
Hurricane Humberto. And this is a massive feat. You have to understand, the ocean is just incredibly hostile to electronics. The salt water corrodes everything, and the sheer force of the waves just destroys hardware.
And usually to get data from inside a hurricane, you need huge, expensive equipment.
Right. Or you just accept that your sensors will be destroyed. Ocean's micro-robots achieved what they're calling a trifecta. They're mass deployable, they're cheap, and they're technologically advanced.
Usually in engineering, you only get to pick 2 of those.
But they managed all 3, and 3 of their units survived the storm and just kept collecting data. That data is gold for weather forecasting.
And governments clearly agree. They've secured contracts with NOAA and the UK government.
It just proves that you don't always need a massive research vessel to do oceanography. A swarm of cheap, tough little robots might actually be the better solution.
It's incredible. The hardware is evolving just as fast as the software. Speaking of software, let's get into our final segment, the toolkit. These are the trending AI tools you should probably have on your radar.
We'll run through these pretty quickly, but each one solves a very specific problem.
First up, let's just recap Clawdbot.
Right. As we discussed, this is your local proactive agent. It clears your inbox, sends emails, manages your calendar, checks you in for flights. And the key is that you control it all through WhatsApp, Telegram, or other chat apps.
Next up is Context 7.
This one is for the developers listening. One of the biggest pains with AI coding is that the models reference outdated libraries. Context 7 provides up-to-date documentation specifically for LLMs and AI code editors. It basically stops the hallucinations.
Then we have BrainLoom. I like the sound of this one.
It's a local-first learning OS. It turns your PDFs into flashcards. Perfect for students or researchers who need to digest heavy material fast. And again, it's local, so you aren't uploading proprietary research.
Number 4 is Humans in the Loop.
This is more of a community. It's a free community dedicated to discussing agentic coding AI. So if you're listening to this and wondering, how do I actually build something like Clawdbot? This is where that conversation is happening.
Next, Tonkotsu.
Sticking with coding, Tonkotsu lets you manage a whole team of coding agents from a single document. Think of it like project management for AI employees. You're not just prompting one bot, you're orchestrating a squad.
And finally, Qwen 3 TTS.
This is a family of state-of-the-art text-to-speech models. They come in 2 sizes, they support 10 languages, but the really impressive stat here is zero-shot cloning.
Meaning it can copy a voice without a lot of training data.
It needs just 3 seconds of audio. And it does this with extremely low latency streaming, so it's fast, and it sounds startlingly real.
The speed of innovation in the tool space is just relentless. It feels like every single week the bar gets raised.
It does, and if you look at the through line of today's deep dive, from Clawdbot on your Mac to D4RT seeing in 4D to that Swiss hand and Tesla, it's all about autonomy.
We're building systems that don't just wait for instructions.
They perceive, they act, and they persist.
Which I guess leaves us with a final thought. If these agents are becoming proactive, reaching out to us, managing our schedules, driving our cars, at what point does the human become the bottleneck in the loop?
That is the question. Are we the managers, or are we just the slow component slowing down the network?
Something to chew on. That is it for this deep dive. Make sure you follow so you don't miss the next one.
And keep an eye on your inbox. Your agent might be messaging you sooner than you think.
See you in the next episode.